Okay, so let me get the whiteboard thing open and flip my laptop. We're going to do the last two problems that I have for 13.3, which is factoring trinomials by grouping. The difference in this section is that our A times C ends up being larger than we really used last time. Excuse me. Okay. So it's like 4 o'clock in the morning. It won't really let me go down much further. So we're going to do the third example in this section. Okay. So what I have is 3x cubed and then a positive 12x squared. And then I have a, negative 351 x. So I want y'all to see something, right? Like I explained that, if it's in 4 terms, you can factor by grouping, right? Split them in half, do all the GCF work that we've been taught. Whenever I talked about using the AC method, I'd said right here that, it needs to be in 3 terms, but more specifically, it needs to be in this form right here, which is ax squared plus bx plus c. Rubbing my eye. And so the fact that it's in degree 2, right, that trinomial has a degree of 2 is what allows us to actually be able to use the AC method. I'm trying to not use technical words here. Technically it's a quadratic function, okay? Your leading variable is squared, and then the next variable is not squared, and then the last value doesn't have a variable, right? Like that's very specific. It's a formula. It's static. It doesn't change. It has to follow that form, right? Well, if you notice here, it was in that form. And if you notice in our example 3, it is actually not in that form, right? That leading coefficient is 3, and this is just supposed to be a constant. But it's not just a constant because it has a variable. So that's what I want you to notice is if your leading term is being, like the variable is being squared, or is it something else? If it's something else, y'all, what you need to do is pull out the greatest common factor of all 3 terms, and then you're going to go ahead and be able to do the AC method. So looking at my coefficients, I noticed that 3 is my smallest value. Its factors are only 1 and 3. So as far as the coefficients are concerned for greatest common factor, it's going to have to be 3, honestly, because we don't pull out ones, right? And the factors of 3 are just 1 and 3. So all that leaves me with is just 3. So I need to look at my other 2 terms and make sure that they're divisible by 3. Well, I know for a fact that 12 is divisible by 3 because 4 times 3 is 12. And then you could get your calculator and do 351 divided by 3. Personally, there's a shortcut. If the sum of all of your individual values, so your 3, your 5, and your 1, that equals 9, right? 9 is divisible by 3, which means this whole number is divisible by 3. So before I even tried to think about pulling out a GCF, I was like 5, 6, 7, 8, 9. Yes, all of them can be divided by 3. Now let's go ahead and do that math. So, nope, don't do that math yet. JK. I'm pulling out a GCF. You never just look at the coefficients, right? You also need to look at the variables. I apologize. I got excited. I noticed that leading coefficient is with an x cubed. That middle term is x squared, and that last term has an x, right? And I just want a constant. So do they all have an x in common? Yes. What's the smallest exponent? That would just be a 1. Now we divide. 3 divided by 3 is 1. X cubed divided by x is keep and subtract. 12 divided by 3 is 4. Signs are the same, so it's positive. X squared divided by x is keep and subtract. 351 divided by 3 is 117. Signs are different, so it's negative. X divided by x goes to 1. So there you go. Now, I actually have it in the correct form. That's what I can do the AC method on. The only thing is my final answer, I need to remember that I pulled out a GCF, so it will be a part of my final answer, okay? So let's go ahead and do the AC method on what's inside of the parentheses. My A equals 1, which that's nice and pretty. My B equals 4. My C equals a negative 117. When I do A times C, that's 1 times a negative 117, which equals a negative 117. And then here I factor. I always use my 1 and the number I'm factoring. 7, 8, 9 totals to 9, right? 7 plus 1 plus 1. If you want to, though, go ahead, of course, divide by 2. I get a decimal. Divide 100 and I just broke my calculator. 117 divided by 3. Divide by 3. I get 39. I'm looking for 4. So I'm just going to start 117 divided by 4. No, 117 divided by 5. 7 divided by 6. 117 divided by 7. 117 divided by 8. I noticed that after a while, it's probably going to be a fairly large number. Look at that. 9 and 13 works. And what's their difference, y'all? It's 4, right? So if I was to keep going, I notice I'd loop back around. But I see here that this pair of factors has a difference of 4. I need it to be a positive 4, which means, and because, 117 is negative, one of them need to be negative. So, and I need it to be a positive 4, so I'm going to make the smaller one negative. You combine negative 9 and 13 together. Signs are different, so you subtract, keep the sign of the larger, which is positive. That equals my B, which is what we wanted. So this tells me that these are my two factors that are going to expand that middle term. Let's just go ahead and bring this down. Open your parentheses. Sometimes I'll work on the side in my AC method just to not kind of get confused by the parentheses, but I've kind of already written this, so let's continue. My first term is just brought down. My middle term is going to be split. Don't forget your variable on each of them. My last term is just brought down. And then the AC method tells me to split right here in the middle, which is fine, 3x. I'm just separating everything from that 3x, right? Looking at x squared and negative 9x. Coefficients, GCF is just a 1. Coefficients, GCF for variables is an x. Open. X squared divided by x is keep and subtract. 9 divided by 1 is 9. Signs are different, so it's negative. X divided by x, that goes to 1. Bring down your sign. I notice from looking over here that 13 is a factor of 117. And I see here that this is 13. So I know they can have a 13 as a GCF. They don't share a variable, so I just subtract. 13 divided by 13 is 1. Signs are the same, so it's positive. X divided by no x is x. 117 divided by 13 is 9. Signs are different, so it's negative. Close, close. If you wanted to use brackets there, you can. There's a whole bunch of stuff going on. I hope y'all can see that what's inside of this bigger set of parentheses is exactly what we've been doing 100%. I just have that extra set of parentheses because I'm trying to keep it separate from the GCF we originally pulled out so that we could do the AC method, okay? So I've got 3x. I'm going to notice that they have this in common, right? I checked, made sure they were good. I'm going to go ahead and write it one time. What's left over is going to go inside of a set of parentheses together. And that is your final answer. So there, y'all. Please don't do 3 times 351. And that's a lot. Notice first from the get-go, that's not squared and that has a variable. That should be what tells you that you're going to pull something out, okay? All right, so let's do this last example. I have 15x squared, a positive 16xy, and a negative 15y squared. I need to first identify. Oh my goodness gracious. Oh, okay, sorry. I'm trying to move around. I'm very uncomfortable. Okay, so I want to show y'all something. I can do the AC method here because this leading term has an x squared. My constant on the end, my c, does have a variable being squared, but it's not the variable x. This still is going x squared, x, no x. So that's why I can still do it. Okay, if you look here and you see, oh, that has a variable being squared, I can't do the AC method. Let's go ahead and pull something out. Y'all, what? Okay, so 15, 16, and 15, the only thing they have in common is 1, right? They all don't have an X. They all don't have a Y. So once you kind of, even if you question yourself, once you notice there's not a GCF to pull out, notice that as far as the AX squared plus BX plus C, no X, that is true here, okay? Of course, it's, sometimes things are just made to be confusing just to see if you trust your math and understand the process, okay? So don't doubt yourself. Here, my A is 15, my B is 16, and my C is a negative 15. So if I do A times C, what I have here, I got like fat fingers or something. Okay, that's what I thought. I just want to make sure. What I have here is 15 times a negative 15, which equals 225. Signs are different, so it's negative. I'm trying to get to 16. That's what my two factors need to have a difference of. Just continuity, y'all, so that things remain the same. I know 1 and 225 don't have a difference of 16, but it's always good to just start with that first one, okay? Now, 5, 6, 7, 8, 9, I know it'll be divisible by 3. I can go ahead and do 2 at least just to show myself that what I get is a decimal. Divide by 3, I get 75. If it's divisible by 3, it's usually not divisible by 4, but you can go ahead and enter it in anyways. Then divide by 5. Well, it ends in 5, so pretty positive it's going to be divided by 5, right? That still doesn't have a difference of 16. So let's divide by 6. That doesn't work. 7, no. 8, no. Oh, I did 8 again. No, still no. 9. My 9s and my A's are like eerily similar. 9 times 25, y'all. That equals 225, right? When you multiply them together. Because it's a negative 225, one of them needs to be negative. I'm trying to equal my 16, which means because my 16 is positive, I need my greater number to be positive. And the reason why is because here's how you do this. A negative 9 and a 25, if I combine those together, signs are different. So you subtract, keep the sign of the larger so it's positive. That equals my B, and that's what I need. Okay? So my negative 9 and 25 are going to be what's going to basically rewrite my middle term. Oh, talking, writing, thinking, like it's a lot. I noticed it instantly, so that's great. But whenever I say, like when we're expanding our B term, don't forget your variable. It is literally whatever variables is attached to B. I wrote X and just tried to move on. It's actually XY, okay? And a positive 25, don't forget your variables. negative 15y squared. AC method has been started, right? We're right in the middle part where now we're in the factor by grouping process. What you do is divide down the middle, start pulling out GCFs. 15 and 9, the largest number that's going to divide both of them is 3. Do they both have an x? Yes. I'm going to pull out an x to the first power. They both do not share a y. Now we divide. 15 divided by 3 is 5. Signs are the same, so it's positive. X squared divided by x is keep and subtract. 9 divided by 3 is 3. Signs are different, so it's negative. X divided by x goes to 1. Y divided by no y is just y. And then bring down your sign. 25 and 15, the largest number that's going to divide them will be 5. Do they both have x's? No. Do they both have y's? Yes. Y to the first power is the smallest exponent. This is where we divide. 25 divided by 5 is 5. Signs are the same, so it's positive. X divided by no x is x. Y divided by y goes to 1. 15 divided by 5 is 3. Signs are different, so it's negative. Y squared divided by y is keep and subtract. And now what I do is that last check. Do these match? Yes, they need to completely 100%. That means that this is what they have in common, because this shows me that there's two terms, right? So the actual GCF between these two terms is that parenthesis. Once you write it once, you can kind of look and see. I need to write what's left over inside of a set of parentheses together. And what I get for my final answer are those two factors right there. I knew it was going to be 2 because my problem started with being squared. So that actually will end 13.3. I'm looking around. I don't see my 13.4. If I'm not mistaken, we'll do some special factoring, which will be like difference of squares. There's a possibility we'll do the sum and difference of cubes. I can't remember off the top of my head. So this is 13.3. That'd be 13.4 or 13.5. There's 2 more sections. I'm so sorry. There's 2 more sections of like factoring and the like the special ways some problems can be written. And then the last section, y'all, like literally of 2020, fall 2020, it's been real, it's been fun, is going to be a zero factor property, which is doing everything we've done in chapter 13, and then they add like one little step at the end. So yeah, it's getting down to the very end. Of course, as always, please keep emailing me with any questions that you have, okay? Thanks, y'all. Bye.